Hi, I'm James, the developer of QuickDA. QuickDA is a phone app that helps you easily calculate the density altitude of your current location as well as calculate a forecasted DA for the locations you plan to be in the future. In this video, let's take a look at the interface and basic functionality of the QuickDA app. On the top section of the application, we have a density altitude calculation prominently displayed. Under it, we have the data bar that displays the location that this DA calculation was created for, as well as the time it was created. In the bottom half of the screen, we have our Environment tab, with our environment inputs that we can use to make a DA calculation. Next to the Environment tab, we have the Data Log tab, where we can access our previously saved DA calculations. On the bottom of the screen, we have a navigation bar with the Home button on the left, an Action button in the center, and a Settings button on the right. Let's use the Home button to return to the home screen. Let's create a new DA calculation. I'm on the Environment tab, and I'm going to clear the current input values by tapping the Clear button. Let's use QuickDA to estimate the density altitude at our current location. I'm going to do this by tapping the Temperature icon button, which will get our ambient air temperature from the nearest weather station. And next, by tapping the GPS location icon button, which will populate the elevation field with our current elevation. You can now see that we have calculated a density altitude for our current location. As well, we have the location this DA calculation was created for and the time it was created now populated in the data bar. Temperature and elevation are the two basic inputs that can be used to calculate DA. More advanced inputs such as barometric pressure and humidity can be used to accurize your density altitude calculation. We will get into that in another video. If you would like, you can see how each of these inputs is used to calculate density altitude by going into the settings and tapping on the Information button next to each environment input option to learn more. Let's navigate back to our home screen and the Environment tab. Temperature is the most important environmental input for accurately calculating density altitude. So if you do have a temperature sensor with you and you can get a reading at your physical location, it is advised that you manually input your temperature information. You can do so by tapping into the temperature field, entering your temperature, and tapping Done. Likewise, if you know your current field elevation, or the field elevation you would like to use to make a density altitude calculation, you can tap the elevation field to manually input an elevation. Let's save this DA calculation by tapping the plus action button at the bottom of the screen. Because we use the GPS location icon to get our elevation, a name has already been given to this location, but we can rename it here. We can also adjust the date and time we want to assign to this DA calculation. By tapping the Save button, we can save this DA calculation into our data log for later. Now let's create a DA calculation for a future location that we're not at right now, but we're going to be traveling to in the future. QuickDA makes getting a density altitude prediction for a future location and conditions simple, more so than any other app or tool available by using the precise field elevation of a location and the temperature. I've got an upcoming match at Parma Gun Club in Idaho next weekend, and the match is scheduled to start at 9 a.m. Saturday morning. Let's calculate a density altitude for this upcoming match. First, I'm going to tap the Map icon button under the elevation field. This is going to bring up the Map feature. In the Search Location field, I'm going to type in Parma Gun Club, Idaho, to orient the map to the location of my match this weekend. I can use Street, Terrain, or Satellite View to help me precisely set my selected location. I'm going to tap on the map to select the exact location I would like to use, and then tap the Set Location button at the bottom of the screen. Now the exact elevation of my selected location has been loaded into the elevation field. Next, I'm going to input the temperature. If I wanted, I could tap the Temperature icon button and the app will get me the current air temperature of the selected location I just set at the Parma Gun Club. It looks like it's 88 degrees there right now. But my match starts at 9 a.m. on Saturday morning, and from the weather forecast, it looks like it's going to be 55 degrees. So I'm going to enter that by tapping on the temperature field and manually entering the Saturday morning forecasted temperature. I now have a density altitude estimate calculated for my Saturday morning at Parma this coming weekend. Let's save it to the data log by tapping the plus action button. Let's rename it Parma Morning. Let's change the date to this coming Saturday. and let's change the time to 9 a.m. I'm going to tap Save to save this into the Data Log tab for later recall. You can now see that the updated location, Parma morning, and time, 9 a.m., have also been assigned to this DA calculation after it has been saved. Using accurate ambient air temperature paired with elevation can give us a density altitude calculation that is typically within plus or minus 500 feet. This is accurate enough for some applications, like planning out hard dope cards in case electronics go down. Let's now tap on and explore the Data Log tab. Here we can access our saved density altitude calculations. Each data log entry has the location name, time, and date, along with the calculated DA. It also lists the environmental input types that were used to create this calculation. At the top, you can see the latest entry I just created, Parma morning, for my match next weekend. Now thinking ahead about my match, I can see in the forecast for Saturday there's going to be a decent temperature swing, with a high of 75 at 2 p.m. I'm going to generate a second DA calculation for the high temperature of my match day. Instead of inputting all the information for that location again, I can simply bring the data from this entry back into the Environment tab by tapping it to highlight it, and tapping the up arrow action button to recall this data back into the Environment tab. I'm now going to adjust the density altitude calculation to accurately reflect the high of the day, which is forecasted to be 75 degrees, by adjusting the temperature input field to 75 degrees. Now that I've calculated the density altitude for the high of the day, I'm going to save it back into my data log. I'm going to name this data log entry Parma afternoon, set the date to Saturday, and update the time to 2 p.m., which is when the high of the day will occur. Let's go back into the Data Log tab. Now, at a glance, I can see the prediction of my density altitude change between my morning and afternoon conditions at my upcoming match on Saturday. To edit the name, time, or date of entry, or delete an entry, tap and hold. This has been an introduction to the interface and basic functions of QuickDA. Follow along for further videos that will go deeper into using inputs such as barometric pressure and humidity that can be used to further refine the accuracy of your density altitude calculations.